Nothing new here in this section. We're just going to investigate how we can use permutations and combinations to help us solve probability questions. Let's say this was a question. I want the probability of drawing 2 kings out of the deck. The old way, or one way of doing it, would be to say, well, the probability of drawing the first king would be 4 out of 52, because there's 4 kings in the deck. And then the chance of getting the next king would be 3 out of 51, which, what do we do on the calculator? 4 out of 52 times 3 out of 51 is 1. A 1 in 221 chance of getting 2 kings. Let me show you another way how to do it, though, using permutations and combinations. Remember, probability is always the number favorable divided by the total possible. Right? Is how we always determine probability. That's why we said there are 4 kings in the deck out of the 52. Well, what if we asked ourselves how many ways could we select 2 kings out of the deck? We know there are 4 kings in the deck, and we want to choose 2 of them. Those are our favorable things. We've got 4 kings, we want to choose 2. The total possible ways of choosing 2 cards would be all of the cards, 52, choose 2. So 4 kings, I need 2 of them out of 52 cards that I'm selecting 2 from. And let's see if we get the same solution. Putting it into the calculator gives a decimal, which I need to convert to a fraction, and yee-haw, same probability. So this is just another thing that you can have in your toolbox, another way of finding probabilities. Let's look how we might use combinations to solve another question. This example here, we want to figure out what is the probability that if we're dealt 5 cards, the probability of getting 2 aces, the 7 of hearts, and 2 other cards that are not the 7 of hearts or 2 aces. Well, we know there are 4 aces in the deck, so 4 choose 2. We know that there are only 1 7 of hearts. The 7 of hearts is there's only 1 card, so there's only 1 in the deck, and we want that 1, so 1 choose 1. Now here, this last one's a little bit interesting. We want 2 other cards. These 2 other cards obviously can't be the 7 of hearts, and they can't be aces either, otherwise we would have 3 aces, and we only need 2 here. So 52 cards in the deck. They can't be an ace, so subtract 4 of those cards, we're down to 48. And it cannot be the 7 of hearts. That means that there are 47 cards that are favorable, and we need to choose 2 out of the 52 cards in the deck, and we are choosing 5. So the probability would equal 4 choose 2 times 1 choose 1 times 47 choose 2 divided by 52 choose 5. And working that out on the calculator, we get 0.0025. So not very good odds of getting 2 aces, the 7 of hearts, and 2 other cards. But there's another example again how we could use combinations to help us find probability. And in this final section here, we will take a look at what we call the Binomial Theorem, which is another method to help us find probabilities. Remember back when you're dealing with binomial data, binomial means 2 outcomes, so success or failure. So this will only work for problems that are binomial, such as a coin. A coin either shows up heads or tails. There's only 2 outcomes. So I'll show you how we can use the binomial theorem to help us solve this problem. A coin is tossed 3 times. What's the probability of getting 1 head? Well, if you did this the long way, you would say it could go heads, tails, tails. It could go tails, heads, tails, or it could go tails, tails, heads. Those are the only possible ways of flipping a coin 3 times and ending up with one head. And if you work this out, the probability of getting a head is 1/2, and then a tails is 1/2, and getting a tails at the end is 1/2. So this probability would be 1/8. Or we could work this out. So tails, heads, tails. The chance of that happening is 1/8. And once again here, this last way of doing it, of course, is also 1/8. So 3 ways of getting one head, 1/8 plus 1/8 plus 1/8 leaves an answer of 3/8. But there's a much quicker way than having to list these all out and consider all the options if we look at the binomial theorem. And the binomial theorem looks like this.
When only 2 outcomes are possible in an experiment, the probability of x successes is probability of x is equal to NCx times the probability to the power of x times 1 minus the probability to the power of n minus x, where n represents the number of times the experiment was performed, p represents the probability of success, and x represents the number of successes that you desire.
And so while the theorem might look a little bit complicated, it's really actually not all that bad. The probability of getting one head is equal to 3 choose 1. 3 tosses of this coin, I want to choose one head. The probability of getting a head is 1/2, and I want one of those. And the probability of getting tails is 1/2, and I need 2 tails. So what this does, what this part of the formula does, is it simply gives us 1/2 times 1/2 times 1/2. It's like the heads times the tails times the tails. So that right there is the same as 1/2 times 1/2 times 1/2. It's this. What this does here in the formula, the combinations, is it lists all the different ways that we could have one head out of the 3 tosses of the coin. So this here, 3 choose 1, is 3 to account for the fact that there are 3 outcomes of 1/8. And when we do this on the calculator, we get 3/8. Okay, so a fairly straightforward formula. Let's look at another example. A die is rolled 5 times, so this is a standard 6-sided die. What's the probability of getting a 6 twice? Again, we recognize this as binomial. You're either going to get a 6 or you're not going to get a 6. So the probability of getting 2 6s would be 5 tosses of the
Die.
Choose 2 6s. The probability of getting a 6 is 1 in 6, and we need 2 of those. And the probability of not getting a 6 is 5 in 6, and we would need 3 of those. So working this one out in the calculator, we get 0.16. So approximately a 16% chance of getting 2 6s when you roll the die 5 times. We'll look at one more example. A die is rolled 5 times. What's the probability of getting at most 2 6s? So we've actually got 3 questions to do here. Because it says at most 2, that means we want to find the probability of getting no 6s, plus the probability of getting 1 6, plus the probability of getting 2 6s. So at most 2 6s. And we need to work each one of these out individually and add them together. So what's the probability of getting 0 6s? Well, if we were doing the binomial theorem, That's 5 tosses of the
die.
choose 0 sixes. The chance of getting a 6 is 1 in 6, and we want 0 of them. The chance of getting something that is not a 6 is 5 in 6, and we want all 5 of those. The probability of getting 1 6 out of 5 rolls of the die. 5 choose 1. 1 6 to the power of 1. 5 6 to the power of 4. So in other words, four numbers that are not 6, one number that is a 6, and the probability of getting 2 6s be 5 rolls of the die. Choose 2. 1 6 to the power of 2. 5 6 to the power of 3. So let's just double check this. No 6s. 5 that aren't 6. 1 6. 4 that are not a 6. 2 6s. 3 that are not a 6. So we'll calculate each of these out, and we will add them all up. And I get about 90%, 0.90 when we add all 3 of these